All right, here we go. 10-6, 10-6. By the way, that week we will be turning in your book around that time so that his mama can find you. All right. Ooh, am I right? On 10-6. Okay. Okay, here we go. So, today we're doing parametric. And what parametric is notice we have this equation. Okay? So with this equation, what I can do is put it in terms of another variable. That's really what parametric is. X and Y are in terms of another variable. Okay? So like, for example, if I said X is T, what is Y? What do you guys think? X is T. Oh, somebody's got it. Oh, we just changed into parametric. Okay? So notice both X and Y are in terms of one variable. Does that make sense? So, if I gave you this parametric graph, how would I graph it? Well, instead of having a t-chart, I got a pie chart. Because I have t, x, y. Oh. I'm going to plug values in for who, do you think? Notice usually on this one I put in values for x, don't I? Does that make sense? But this case, I'm going to plug values in for t. And so on. Usually they have a restriction. Sometimes they have a restriction like we did here. Does that make sense? Do we see what I'm doing here? But you got to think about this as kind of also as kind of like, huh, you're moving in a progression. Right? So a graph is being graphed in this progression. Okay? So here's what we got. We still get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm really only going to work with the even numbers because it's divided by 2. Does that make sense? So this is 0. What do we get here? Plug in 2 for t. 4 divided by 2 is 2. 2 plus 2 is 4. And when we plugged in 4, we had 4 plus 4, which is 8. When we plugged in 6, 24. When we plugged in 8, that's 64 divided by 2, so that was 40. And then that was 60. You guys remember just doing that just basically on this? I was preparing you guys. With 12? Okay. Awesome. So here's what that graph looks like. We all saw earlier 1, 2, 3, 4, 5, 6, 6, 6. Okay. We had 0, 0. 2 was 4. Anyway, it kind of had that shape. Right? But what you do here is I put these dots. Huh? That's what your mama said? It's because we should do right things the first time. What was 6 again? 24. 8 was 40. And then 60, right? So what we do here, though, is we put these values by it. Does that make sense? What we plugged in? Yes? Okay, and then we connect them. Okay, but actually I stopped right there because I was only going to that part. And then I put a direction. Okay, That's how it's progressive. Does everybody understand how you would graph a parametric? That's the way, I'm going to show you on the next one why it's important. Yeah, it's a little different. Okay. Let's try another one. Let's go ahead and graph. Okay, so there's our parametric. Everybody good with that? Yes, no, maybe so? I like that you smile on me. You made me feel better. Do you know, Nate, my mom would never let us have eggs when we had French toast. She's like, the eggs are on the plate. We were never allowed to have eggs in French toast. I'm just, because you put the eggs, you know, the toast in it, and so she's like, there's already eggs on it. We never run out of bread. We got like up until my wife puts like 30 loaves of bread in our house. Okay, we're gonna do our pie chart. T, X, Y. So now this one's a little bit different because X and T are not the same thing in this case. Right? Does that make sense to everybody? So what numbers are we gonna plug in for T? I'm gonna plug them all. Because it tells us what T values between -2 and 2. I am Groot. Right, you are. Anybody have this mechanic? I just saw that he's getting his food load ready for FedEx. It's pretty interesting. Got all these caps for like Yoda. Who's the dude with the crazy face? No. He's on the Avengers. Thanos, dude, the guy with the diamond or something. Oh, Mr. Roberts. I said it first. All right, here we go. So, if we plug -2 in for T, what's X going to be? -2 squared? 4. 4 minus 4? 0. Then I'm going to plug in Y. 0 divided by 2. 0. Oh, excuse me. No, you're right. I'm wrong. -1. Because I'm plugging -2. -2 divided by 2 is -1. So let's graph this at the same time. So this is at 0, -1. This is where we started. This was at T equals -2, right? Is everybody with me on that? Yes, because I plugged in the point 0, -1. Okay, let's plug in -1. -1 squared. 1, 1 minus 4, -3. -1 divided by 2. -0.5. Is anybody not understanding how I'm getting these values? I'm plugging these values into the X equation and to the Y. Yes. Okay, so -3.5. That was T equals -1. So far we're connected to there. Okay, now I'm plugging in 0. 0 squared. 0, 0 minus 4, -4, and then I get 0. That was T equals 0, and it's going like that. So bring with me so far. Plot and point, right? Okay, plug in 1, 1 squared. 1, 1 minus 4 is -3, and this time though I get 1/2. Now we're going to plug in 2. 2 squared. 4. 4 minus 4. 0. 2 divided by 2. 1. Does everybody understand how this chart came about? Yes, sir.
When you're putting like the coordinates in, you're putting the XY coordinates
Uh-huh.
in, except where T is.
And then I'm just telling it that's what T was. So then, notice then I put my direction. This is kind of like if we were talking about a particle. You guys know when you talk about in physics and things like that, we have particle movement. Oh, sure. I don't apply my math, guys. I just do that. All right. So notice it's just telling you the direction of what's happening. Okay. Is everybody with me there? Was that too hard? Okay. Could we do the domain of x? What's our x domain? -4 to 0. Right? What's our range? Right? Let's do that. We can still find domain range from our graph. The x is 0. So then we go from -4 over to 0. Because we have a certain amount. You wake up, Jacob. Point. What's happening? Right. Now, there is times though they want you to eliminate the parameter. Eliminate the parameter means, hey, let's go back to just rectangular. Rectangular means XY coordinates. I no longer want T. Right? Anybody have an idea of what we'll do? We got to solve for T. Now, in one of the equations, is it easier to solve for T than the other?
Yeah.
The bottom's a lot easier. Would you guys agree with that? Okay. So 2y equals T. Agree? What can I do then? Now I'm going to substitute, correct? X equals 2y squared minus 4. Agree with me on that? So that would be x equals 4y squared minus 4, where you might want to say that y is between 1 and negative. Why did I put that? Because those are values I can only plug in because keep it the same as what we have. That's why we want to kind of always think about our range, right? Because what was our range on our graph?
What was this for the graph? The other one?
The same information, right? In this case, because notice we have y being solved. X equals, and I don't want to really play around with that or anything. Here we can just leave it. Because the goal was to get rid of the t. Right? That's eliminating the parameter. Okay? Feel good so far? Does everybody understand where this came from though? Okay, so look at what we had on that graph. What was our range on our graph? For y, right? And for our y, so I'd be -1 to 1 to make sure we still have that space. Why are you applying? Because see how x is solved for y? Now if it was vice versa, then I go with the x. Okay. Answer it? But it's not always negative, no, it would be, what is x? What was the
Oh,
domain?
yeah, it is -4.
-4 to 0. Right? Okay? I know, bottle flip in my hand. Okay. Ooh, this one's a little bit. No. Hey guys, look at this one. Wonder what that looks like. Eliminate the parameter. We're going to eliminate the parameter. So what does that mean? Solve for t and then substitute back in. Is there one that's nicer than another? Which one's the nice one? Probably the x. Because I can square it right now, right? Don't you guys love when I teach it? But all this stuff is stuff that we've already learned. You just didn't know what the heck you were doing. Do we all agree with that? Because this is, we've done this in the past. Then what? Well, I like to flip it when we're in fractions. See how that's a lot easier to flip it? Agreed? Aren't you so excited you sit up? Is Aiden sat here? I'll get quick. I like that shirt though. That's a good color shirt. We could do that, or we could say 1 minus x squared over x squared. Right? Then what? Plug it in for t, right? That was t plus 1, so I'm going to plug this guy in. 1 minus x squared over x squared over, is it t plus 1 on the left? Is t over t plus 1? Which, we don't like that. That's not very, we don't like fractions over fractions. What can I times to everything to get rid of it? If I times this by x squared and this by x squared, what would I do? Those just cancel out. Is everybody with me on the top? And then I'm going to distribute this through. So if I distribute to him, what happens? What's left over? And then distribute to him. And then what is that? Just 1 minus x squared. Right? So what is this? Just a parabola. Would we have known it was a parabola beforehand? You guys probably thought it without eliminating that parameter. Maybe not. Right? You have a question?
Yeah. So how'd you get to the section?
Okay. Give me 1 second. Let me get some water. Some water. Did you see my face box up there? Did you see it? You saw me, but I didn't see you. Okay, the reason where it came from is we knew that t was x squared over 1 minus x. Is that what I said? No, right here. 1 minus x squared over. So that's what t was. Well, y was t over t plus 1. I just substitute. With me? All right, we eliminated the parameter. Good? Now, the parameter didn't have any restrictions, so nor does it. Okay? Now, there's times that it's going to give you, okay, just a regular old equation. This can give us an equation, like this. And they want you to eliminate the parameter, not eliminate the parameter, but put it in parametric. Right now, what's this in? Rectangular. It's just x and y. Does that make sense to everybody? So we are going to then put it into parametric. What do you guys think I'm going to do? I'm going to say x is t. So what is y? Hard, huh? Does that make sense? Isn't that the same thing? Okay. What if I go to a new stage? x is equal to t minus 1. Or, yeah. So y would equal 1 minus t minus 1 squared, which I probably would go a little bit further, which is just t squared, negative t squared plus 2t. With me? Now, they might tell you to say, all right, eliminate the, or put it in parametric if this is the case, or if this. In right here it is. Right. Everybody good? Okay. Now, those are when we're just nice XY coordinates. What if they're trig coordinates, though? My boy got one of them. Okay. This one. Eliminate the parameter. What's our parameter this time? Theta. Should I graph this? Oh, let's first off graph. Okay. So in our little pie chart here, we have theta x, y, right? What's a nice number to plug in for theta? Yeah. I'm not going to plug in 1. I like 0. I like 0. Cosine of 0 is 1. 1 times 4 is 4. Plug in 0 for theta. Sine of 0. 0. 0 times 4. So far we're at 1, 2, 3, 4. Good. Let's do pi half. Cosine of pi half. 0. 0 times 4. 0. Sine of pi half. 1 times 4. Okay. This is what it means. I will, yes. Yeah, you can do that. T equals, or theta equals 0. Theta equals pi half. It kind of makes sense. Okay, then what's the next one? Pi? Cosine of pi? Negative 1 times 4. And this is 0. Huh, I wonder are you guys see what this is? Huh? How about 3 pi half? 0 and negative 4. And then let's go back to 2 pi. And I get what? 4 and 0. And then it just basically going in that direction. So we have a question on how you might do that. Some other things you might find out, it could be ellipses. It could be hyperbolas. You guys learned about hyperbolas and ellipses last year. A hyperbola is this looking. Where you have a vertex and a focus. You guys should have learned that last year. Okay, is everybody with me on that? All right. So this is a circle because they have equidistance. Right? Do you remember the basic equation of a circle? Okay. Okay. Ooh. Can I surplus it to another equal? Okay.
Yeah, I'll bring it up.
Please.
I'll bring it up.
Thank control within the district, it doesn't matter. They're full. Okay, so let's come back down here though. Let's rewrite this. So let me show you guys some. Oops, kind of gave it away. Hope that's cosine. Okay, I'm going to square both sides. Here's the reason. Oops. Right? Matt sitting back there like this. Playing Matt. Matt was playing. Oh, yeah. Okay. Let's add those two rows together. Just like we do with elimination. Just hold your phone. What do these two share? What's left over? Oh, one. Whoa. Which is good. And isn't that the equation of circle? X squared plus y squared is r squared. Right? And you guys remember doing some of that? But you see, by squaring it, we allowed those ones out of there to become one. So we eliminated the theta. Okay, should we do another one of those? What if it was this? Aw, Nicola's getting more birthday. Hey, that's a nice pencil sharpener. I know. You know, it took me like 7 years of teaching the final find the best. I had another pencil sharpener. It would just die every year. I think I'm strong for a good 4 or 5 years. Is that what you think hurt that? Whoa. How do we eliminate the parameters? I want just cosine by himself, and I want this sine by himself. Okay, is everybody with me there? So that x minus 4 equals cosine theta, y minus 3 equals sine theta. What do we do? Square it.
Pardon the interruption. Could I please get Noah McCord down to the attendance office for a couple of minutes, please?
I suppose.
Thank you.
2 minutes. You better run this. Am I not right? Does that make sense, everybody? When I add these two rows together, I'm going to get x minus 4 squared plus y minus 3 squared equals 1. Could we graph that if we wanted to? Sometimes it's nicer to graph it in the rectangular form than it is the parametric. Can anybody tell me what shape this is still? Still a circle, but what happened? Our center has been shifted. Instead of being at 0, 0, our center's at 4, 3. So we're out here, 1, 2, 3, 4, up 3. And then notice what's our radius? 1. So we're going to go up 1, down 1, over 1, over 1. My circle really sucks. Right? Because our radius is 1, so I'm going 1 in all directions, north, south, east, and west, vertically and horizontally. Yeah? I'm on a square. Okay. I think that's it, guys. That's it what we're gonna do, because I'm not gonna do the side chores. Hey. Here we go, guys, here we go. I couldn't go in by too fast. Sorry, buddy. I'm worried about you. No, just, I'll have it ready by Monday. How about after school? Yeah, and then I don't feel comfortable with whoever just said that. You see your head. Love you, though. That is one white shirt. It is a very lovely shirt.